Good afternoon, ma'am. I am Mani Sharma. I am here to explain about Q networks, deep Q networks, policy optimization. Introduction to reinforcement learning. Reinforcement learning involves training agents to make sequential decisions to maximize cumulative rewards. It models the interaction between an agent and its environment through states, actions, and rewards. Q networks and deeply policy optimization are advanced methods within this framework to improve learning efficiency. We can see a type of machine learning where an agent learns to make decisions through trial or error by interacting with an environment. And we can see Q function and Q learning in AI. The Q function estimates the expected cumulative reward of taking an action in a given state. Q learning is a value-based algorithm that iteratively updates Q values using the Bellman equation. It aims to find the optimal policy by selecting actions with the highest estimated Q values. And we can see limitations of traditional Q learning. Traditional Q learning struggles with large or continuous state spaces due to tabular representations. It requires intensive exploration and can be slow to coverage in complex environments. And function approximation methods are needed to scale Q learning to high dimensional problem. Like we can see lack of flexibility and pace limited engagement from passive learning in the Q learning. And we can see introduction to Q networks, deep Q networks. Deep Q networks combines Q learning with deep neural networks for function optimization, and they use the neural networks to estimate Q values directly from raw input states like images. And deep Q networks enable reinforcement learning in environments which high dimensional sensory inputs. And and we can move for architecture and training of deep Q networks. A deep Q networks typically consist of convolutional layers followed by fully connected layers to process input data. The network is trained to minimize the difference between predicated Q values and target Q values using experience reply. Experience reply stores past experiences to break correlations and stabilize training. And we can see the image how to improve deep Q networks training. Firstly, we have to invest in hardware. Deep Q networks training requires powerful CPUs. It needs powerful CPUs to execute this. And tune exploration strategy, balance exploration and exploitation. And we can see the design reward function, craft affection of function. And we can move for key techniques in DQ networks implementation. Target networks are used to provide stable Q value targets and prevent divergence during training. Epsilon greedy exploration balances exploration and exploitation during learning. Clipping rewards and other normalization techniques improve training stability. And we can move for policy optimization methods. We can see the policy optimization based on methods directly optimize the policy function rather than the value function. They are suitable for continuous action spaces and can handle stochastic policies. Like example include reinforcement, actor citric, and proximal policy optimization. And we can see the example for this actor citric algorithm is example for DQ learning network. Actor citric methods combine policy and value networks for more efficient learning. The citric estimates the value function guiding the actor to improve policy decisions. These methods often achieve faster convergence and better stability compared to pure policy based algorithms. And we can see advantages and challenges of deep policy optimization. Deep policy optimization methods can handle complex high dimensional environments effectively. They require careful tuning of parameters and can be simple inefficient. And stability in training is a key challenge addressed by techniques like PPO and trust region methods, and we can see the conclusion and future directions. Q networks and deep policy optimization are powerful tools for scalable reinforcement learning, and combining value based and policy based methods can leverage their respective strengths, and ongoing research aims to improve sample efficiency and stability and applicability to real world problems. And thank you for listening my presentation, ma'am.